NASA recently received a set of strange and confusing transmissions from the Voyager 1 spacecraft. Having journeyed through space for more than 4 decades, Voyager 1 had traveled into regions of the solar system that had never been explored before. These new signals, filled with garbled information and glitchy output, immediately raised concerns and triggered a tense investigation. Experts analyzed the data and discovered some anomalies in the probe's performance as it transmitted these enigmatic signals back to Earth. What could have caused such a strange transmission of information? Was this due to a malfunction or something more extraordinary? Could it even suggest that this space probe had been tampered with by an otherworldly force? To address these questions, we must first understand how Voyager was designed to function and what makes it so remarkable. Voyager stands as one of NASA's most successful and enduring space missions. Originally envisioned as a space grand tour of the solar system, the mission became not only NASA's longest-running space program but also the largest planetary expedition in history. The Voyager missions explored more planets, discovered more moons, and returned a greater volume of images and data than any other mission. The origins of the Voyager project trace back to the discovery of a rare astronomical event known as planetary alignment, which occurs approximately once every 175 years. During such alignments, multiple planets line up closely on one side of the Sun, making it possible to observe them in sequence. In 1964, a NASA engineer at the Jet Propulsion Laboratory noted that there would be an alignment of Jupiter, Saturn, Uranus, and Neptune in the late 1970s and early 1980s. This discovery inspired the Jet Propulsion Laboratory to popularize the event and advocate for what became known as the Grand Tour project. The Grand Tour plan called for a series of spacecraft missions that would take advantage of gravitational assistance from each planet to save both time and fuel. Initially, this ambitious mission included 4 spacecraft with a projected cost of around $1 billion. However, the plan was ultimately scaled back due to budget constraints and technical challenges, with congressional pressure further reducing it to just 2 spacecraft. Even though the project faced budget cuts, the 2 Voyager probes, Voyager 2 and Voyager 1, were successfully launched, marking the beginning of an epic journey to the outer regions of the solar system. Voyager 2 was the first to launch, taking off on August 20th, 1977, from Cape Canaveral Space Force Station in Florida. Voyager 1 followed 2 weeks later, embarking on its own path to explore the solar system. Each Voyager spacecraft was outfitted with a suite of 11 essential instruments designed to study planetary bodies during encounters. Among these instruments were an imaging science system with narrow and wide-angle cameras for capturing photographs, a radio science system to determine physical properties of planets, and an infrared interferometer spectrometer to investigate energy balance and atmospheric composition. The Voyagers were equipped to measure atmospheric properties, magnetic fields, surface composition, and magnetospheres, and these instruments formed the basis for much of what we know today about the outer planets. In 1979, Voyager 1 began photographing Jupiter, reaching its closest approach in March of that year, at a distance of about 217,000 miles from Jupiter's center. During this flyby, Voyager 1 sent back incredible images of the planet, its moons, and its magnetic fields, most of which were captured within 48 hours of the closest approach. One of its most remarkable discoveries was that of ongoing volcanic activity on Io, Jupiter's 3rd largest moon. This was the first time that active volcanoes were observed on a body other than Earth, a revelation that thrilled scientists and ignited further interest in Io's volcanic landscapes. These volcanic activities were later found to be the primary source of sulfur, oxygen, and sodium in Jupiter's magnetosphere. Following Voyager 1's success, Voyager 2 also approached Jupiter and transmitted a total of 177,000 images of the planet and its moons back to Earth. Among its discoveries, Voyager 2 confirmed Voyager 1's observation of a thin ring encircling Jupiter and found 2 previously unknown moons named Thebe and Metis. Using Jupiter's gravity to adjust their trajectories, both Voyagers continued their journeys to Saturn. Voyager 1 reached Saturn approximately a year later, making its closest approach in November 1980. The spacecraft came within 77,000 miles of Saturn's cloud tops, where it observed the planet's atmosphere and its largest moon, Titan. Among its findings, Voyager 1 discovered that Saturn's upper atmosphere contains about 7% helium, with the remaining volume mostly composed of hydrogen. It also recorded high-speed winds near Saturn's equator, clocking at approximately 1,100 miles per hour. Voyager 1's flyby of Titan was particularly notable. The probe discovered that Titan had a thick atmosphere, marking the first real evidence of another celestial body having an atmosphere similar in density to Earth's. Additionally, Voyager 1 discovered 3 new moons: Atlas, Prometheus, and Pandora, bringing the known count of Saturn's moons from 12 to 15. Voyager 1 also provided breathtaking images of Saturn's rings, revealing that they consist of countless tiny particles and that there are gaps and ringlets within the rings. Voyager's observations helped scientists calculate Saturn's rotation rate and confirmed its diameter at the equator as 120,000 miles. Altogether, Voyager 1 sent back about 16,000 images from its Saturn flyby, greatly enhancing our understanding of the planet. In January 1986, Voyager 2 made its closest approach to Uranus, coming within 50,600 miles of the planet's cloud tops. During this encounter, Voyager 2 discovered 11 new moons of Uranus, including Cordelia, Ophelia, and Juliet. The probe studied Uranus's atmosphere and ring system, revealing that Uranus has a day length of 17 hours and 14 minutes. Voyager 2 also found that Uranus's magnetic field is misaligned with its rotational axis, and that the planet has a helical magnetic tail, as well as clouds that emit ultraviolet light. When Voyager 2 examined Uranus's moon Miranda, it revealed huge canyons thought to be the result of geological faults. Some scientists believe Miranda may have shattered and reformed in the past due to a violent impact. Voyager 2 continued on its journey to Neptune, making its closest approach in August 1989. The spacecraft passed through Neptune's Triton system, observing a phenomenon known as the Great Dark Spot, which was likely a high-altitude methane cloud. Although the Great Dark Spot has since vanished from view, the Voyager mission's observations of Neptune marked the first time every known planet had been visited by a space probe. The highlight of the Voyager mission came in 1990, when Voyager 1 took a solar system family portrait. Composed of 60 images, including 6 planets and providing an unprecedented perspective on Earth's place in the universe. Captured from beyond Neptune at a distance of 3.7 billion miles from the Sun, this series of images became famous for depicting Earth as a tiny pale blue dot within a scattered ray of sunlight. After completing their planetary missions, the Voyagers entered a new phase, transitioning into interstellar exploration. Voyager 1 made history in 2013 when it became the first spacecraft to enter interstellar space, confirming its location by detecting changes in the surrounding plasma environment. Traveling at 330 million miles per year, Voyager 2 followed in 2018, becoming the second spacecraft to reach interstellar space. The data provided by the Voyagers in this new region have led to groundbreaking insights into the heliosphere, the vast bubble created by the Sun that encases our solar system. Voyager 1 detected an increase in cosmic rays from beyond the heliosphere, along with vibrations in plasma particles, a first indication of the sounds and textures of interstellar space. It also observed changes in magnetic fields and plasma density at the heliopause, the boundary that separates the solar system from interstellar space. This knowledge is expected to aid future missions as they navigate beyond the Sun's influence. Hidden aboard each Voyager is a golden record, a gold-plated audiovisual disc containing photographs of Earth, images of life forms, scientific data, and a medley of Earth's sounds, such as whale calls, a baby crying, and waves breaking on the shore. Intended as a message to any intelligent beings that might one day find the probes, the golden record also features greetings in multiple languages and music from Mozart to Chuck Berry. Celebrating the diversity of Earth's cultures and marking humanity's presence in the universe. After an incredible journey spanning over 4 decades, Voyager 1, which had been transmitting data smoothly throughout its mission, suddenly began sending back strange signals to Earth. This unexpected behavior immediately caught the attention of scientists, who were puzzled because the space probe had consistently maintained excellent working condition throughout its historic mission. Upon closer inspection, scientists found that the data being received from Voyager 1's articulation and control system did not correspond with the actual state of the spacecraft. The articulation and control system is vital because it manages both the orientation of Voyager's antenna and its overall positioning, which are critical factors for the success of space missions. The appropriate positioning of the probe's antenna is crucial for the transmission and reception of commands from Earth's command stations, as even the smallest deviation can degrade or completely disrupt the communication link. Orientation is also particularly important for probes that rely on solar power, as aligning the probe with the sun maximizes solar panel exposure and ensures continuous power for the mission.